All right, so we're just going to go over, here's a simple system. We're going to calculate the current that flows through. All right, so here we have one closed system driven by one battery or EMF of 12 volts and an internal resistance of 0.2 ohms. So here's our current. We have it running through two resistors. R1 is of a resistance of 5 ohms, and R2 is of a resistance of 6 ohms. So the first thing we do, just like is to determine the direction of current. And we determine that the current goes from plus to minus is our standard convention, and so the current is running in this direction. Now, we can do the loop rule, as we'll do, which is this Kirchhoff's second rule. We can either do it in the clockwise fashion or counterclockwise fashion. I'm going to choose to go in the direction of current. There's no reason why you can go one way or the other. The numbers work out to be identical. Okay. So the first thing we have to do is follow the current from the point source. Okay, so we're going to start here and move around. And the first thing we encounter is R2, and it has a resistance of 6 ohms. So we're moving over the resistor counterclockwise while we're performing a loop rule, and we traverse it in the same direction of current. So we're going to write I1 R2 minus. Okay, and then as we continue, the next thing we do is we hit another resistor of 5 ohms, and we're still moving in the direction of current. So we're in the direction of current over the resistor. So again, we're minus I1 R1. We move back around, keep going through the circuit, and the next thing we encounter is the internal resistance I1. Again, still moving in the direction of current. So minus I1 R1, and then we encounter the EMF. Okay, and if we look over the EMF and we're traversing it in the orientation of negative to positive in the direction of current, then that means we must add our EMF voltage, and our loop rule says that that is equal to 0. Okay, so the next step is to solve for I1. So what we can do is pull out negative I1, so that we're left with negative I1 times R2 plus R1 plus R1 plus our EMF is equal to 0. We subtract the EMF from both sides to get minus IR1, R2 plus R1 plus resistance 1, okay, is equal to minus EMF. Divide both sides by this units of R, and so we equals minus I1 is equal to minus EMF over R2 plus R1 plus R1. Now what we're going to do is multiply both sides by minus 1 to get rid of the minus I over here. So we're left with I is equal to EMF over R2 plus R1 plus R little 1. And when we substitute in our values for I, we get I is equal to 12 volts. And we add up our 6 plus 5 plus R1 of 0.2. And so it's 12 volts over 11.2 ohms in resistance. And that comes out to be 1.0 amps. And so through this, the current running through this system is 1.0 amp. So we had to identify the direction of current. We had to use our traverse rule so that our summations of our voltage drops, which is what our IR is, was appropriate. And then we had to set that equal to 0 to obey Kirchhoff's second law, which is our conservation of energies. Because as we remember, voltage is also a potential energy. Even though we usually just call it a potential difference, it is a potential energy. And so we're conserving the energy as we go through our circuit. And that gets conserved by our conservation of current.